This is the Colorado Professionals in On-Site Wastewater presentation on percolation tests. Percolation tests are covered in the Colorado Department of Public Health and Environment Regulation 43 and Section 43.5D. Regulation 43 requires a visual tactile analysis of the soil in at least 2 soil profile test pit excavations. Percolation testing may also be conducted if the long-term acceptance rates from the visual tactile analysis and the percolation tests don't agree, the designer must use the more restrictive LTAR. Percolation tests are not required when conducting a visual tactile evaluation in soil profile test pits. However, it may be worth the time and effort. We've seen situations where there has been construction traffic over the area that was set out to be the soil treatment area. Also, where you see fill soil, you may want to conduct percolation tests. This provides additional data to identify and evaluate limiting layers, confirm visual tactile analysis, and establish infiltrative surface elevations. Regulation 43 outlines who can perform a percolation test. A professional engineer, a trained person under the supervision of a professional engineer, or a competent technician may perform percolation tests. Competencies needed include setting up equipment, performing and running the tests according to the procedure outlined in Regulation 43, recording results, and calculating rates. Local public health agencies may approve training. If you're going to conduct percolation tests, you will want to determine where those tests will be located. The plan view location determines the location of the soil treatment area. So where on the site are you going to place your soil treatment area? Percolation test depth or elevation determines the soil treatment area infiltrative surface depth elevation. If you change the soil treatment area location, you need to do another percolation test. You will need at least 3 holes to conduct your percolation test within the area of the soil treatment area, spaced evenly over the soil treatment area. This is why it's important to do the visual tactile analysis of the soil first, so that you know the approximate size of your soil treatment area. You will also need to determine the depth of your percolation holes. This may be driven by site elevations if you are trying to gravity flow from the septic tank to your soil treatment area. If the infiltrative surface depth or elevation is uncertain, do percolation tests at more than one depth or elevation. You can use your soil profile hole to determine elevation or depth. Is there a change in the soil? Do you have a limiting layer that you need to maintain a vertical separation? There is a minimum of 2 holes that need to terminate into a changed soil. Any limiting layers encountered in your soil test pits will influence the infiltrative surface elevation of your soil treatment area. Here in Regulation 43, Table 7.2, we can see the separation distance requirements for the infiltrative surface of soil treatment areas receiving different treatment levels of effluent. We can see here for treatment level 1 and 2, that 4-foot separation is required unless we have pressure dosing, then the separation distance is 3 feet. Pressure dosing is required for treatment level TL2N to TL3ND, and we can see that as treatment level increases, the separation distance decreases. If a change of soil, type, color, or structure, and treatment depth of the soil is encountered, a minimum of 2 soil percolation holes must be terminated in the changed soil. Percolation tests must be conducted in both holes. How do you know if there's a change in soil? Because you have already conducted your soil profile test pit excavations and evaluated the soil. What is a percolation test? It's an estimate of the soil's capacity to accept clean water. This is dependent on the method of hole construction and preparation, the soil texture, soil structure, soil consistence, and using the proper procedure. The diameter of the hole matters. The soil treatment area is designed based on bottom area. The larger diameter the test hole, the more bottom area relative to sidewall area than smaller holes. Regulation requires a minimum 8-inch diameter and a maximum 12-inch diameter for the percolation test holes. The depth of the percolation holes should be at the proposed infiltrative surface of the soil treatment area. If the infiltrative surface is uncertain, do percolation tests at more than one depth. The perk hole depth needs to be a minimum of 6 inches below the proposed infiltrative surface and a maximum of 18 inches below the infiltrative surface. Percolation test holes can be constructed using a power-driven auger, a hand auger, post hole digger, or a shovel. Typically, a power-driven auger hole is done from the ground surface, whereas when you're hand excavating it is typically done from a shallow test pit. Here we can see a shallow pit excavated by a mini excavator a couple feet deep, where a hand-dug percolation hole is dug in the bottom of that excavation. When preparing your percolation test holes, you should scrape the bottom and sides of the hole with a knife or blade. Remove loose soil and add 2 inches of coarse sand or gravel to protect the bottom of the hole. You may need to sleeve the hole with a perforated pipe or bucket to keep the hole from caving or sloughing in very sandy soils. After preparing the holes, you will want to load the holes with water. Pre-soaking the holes is required unless the soil is sand with less than 5% minus 200 fraction, which is silt and clay particles. For all other soil, you want 24 hours prior to the test of soaking those holes. Fill the hole to a minimum depth of 12 inches and maintain water in the hole for at least 4 hours. This is rarely done, which is where we see inconsistencies with the percolation results. Here are 2 examples of how to measure the water level in the hole. On the left, we see measuring the water surface. So typically this has a yardstick, a tape measure is typically what is used. You can lay a piece of lath or a board or other object over the hole as a reference point. So when you measure down to the water surface, you have a reference point to take your measurement from. The other method is the float method, which is shown on the right. This is a float that is placed into the hole that is attached to a ruler. So as the float drops, so does the ruler in that contraption. So to start your percolation test, you're going to add water to 6-inch depth above the bottom of the hole. Set a reference point from which you will measure, as we showed in the last slide. Measure the depth at time 0 from the reference point. Measure depth after the time interval, typically 30 minutes. Record the drop in water level and calculate the percolation rate. A standard percolation test lasts for 4 hours. Exceptions to this are sandy soils where 6 inches of water soaks away in the first 30 minutes. The 4-hour test can also be waived if 3 successive water level drops do not vary by more than 1/16 of an inch. Another exception is if water remains in the hole after the overnight soaking period. In this situation, the water level should be adjusted to 6 inches and the water level after 30 minutes should be recorded. There may be other exceptions that you can check on with your local public health association. As stated previously, a standard percolation test runs for 4 hours. Readings are taken every 30 minutes, so you end up with 8 readings over 4 hours. In sandy soils or other soils where the first 6 inches of water soaks away in less than 30 minutes, each subsequent reading is taken at 10-minute intervals over an hour. The total test length is 90 minutes. When recording our percolation data, we want to record the length of the interval, the water depth at the start of the interval, the water depth at the end of the interval. Then we are going to subtract the water depth at the end of the interval from the water depth at the start of the interval to get the drop in the water level. So in the first row here, we have 36 inches minus 34 inches, gives us a 2-inch water drop. And then the percolation rate in minutes per inch. Our percolation rate in minutes per inch is going to be determined by taking the length of the interval in minutes and dividing by the drop in water level in inches. Drop in water level is expressed in inches and fractions of an inch because we are typically using a tape measure. So for example, if we have a 1 3/8 inch drop in water level, we're going to convert the fraction to a decimal. So 3/8 or 3 divided by 8 equals 0.38 inches. So 1.38 inch becomes 1.38 inches. So here are some example percolation rate calculations. Here we have the length of interval in minutes. Each interval is 30 minutes, and then the drop in water level in inches. And in order to calculate the percolation rate, we're going to take that length divided by the drop. So here we have 30 divided by 2. Then we have 30 divided by 1.25. The next one is 30 divided by 5/8, or converting that to a decimal is 0.625. And then 30 divided by 3/8, or 30 divided by 0.375. Here we can see as we do that math, 30 divided by 2 is 15, 30 divided by 1.25 is 24, 30 divided by 0.625 is 48, and 30 divided by 0.375 is 80. Typical deficiencies that cause inaccuracies in percolation testing include averaging the drops over the entire length of the test rather than taking the final reading. In each percolation test hole, the final reading should be the percolation rate for that hole. Failure to pre-soak the holes can also cause inaccuracies. Holes not to the proper depth. The depth of the hole should be 6 to 18 inches below the proposed infiltrative surface. If you do not have your hole at the right depth, you may not be measuring the infiltrative rate at the elevation that your soil treatment area will be at. Starting the test less than 24 hours after starting the pre-soak can also cause inaccurate rates, as well as stopping the test too soon. When in doubt, do the full hour test. We also see inaccuracy from math errors and not showing all readings over the full test. This percolation test module is meant to be viewed in conjunction with the Colorado Soils and Site Evaluation course. The course provides detailed information on soil and tactile analysis of soil test pits and further information to become a competent technician in accordance with Regulation 43. Additional resources are available on the CPOW website about soil texturing, as well as forms for soil logs and percolation testing. Thank you.